very often in data analysis, we collect data, which is called the sample data. We need to understand the difference between a population and sample before moving ahead. Population is something which is not the literal meaning of population as we normally use, but population is based on the context or the relevance of your problem. For example, if I'm doing a research at QUT on what's the students' views on QUT's infrastructure, my population would be all students who are enrolled in QUT programs. So basically, I'm not going to talk to others in the university who are working as academics or administration staff, but only students, because that's my population. Having said that, I may not be able to get the opportunity to get every student's opinion on QUT's infrastructure because that could be very difficult for me. In some cases, it could be very costly, for example, or very time-consuming. And I may just choose to pick a sample of students from QUT and try to make a prediction based on the sample that what the population's view is about QUT's infrastructure. So that is something which is always done by in all surveys or all most of the research you will see. Very common example would be in opinion polls conducted by pollsters leading up to state level or national elections. You will see that people forecasting that this party is going to get 45% or 55% of the popular vote. However, if you look at their population, the population of interest in this case would be all people who can vote in that election, but pollsters typically would be talking to a very small number of people before they make that prediction. So, for example, in a national election, it's quite likely that they'll be speaking to about 1,000 to 1,200 people in most cases to make a prediction about the election results where millions of people would actually be voting. That's done because, again, it's very costly and time-consuming to contact people, and sometimes it may be impossible to contact the entire population, and that is typically the case in the case of a national election. And sometimes, we do want to avoid the destructive effects of certain tests or research. For example, if I'm trying to, let's say, develop and test a new drug for curing a certain disease, I may actually not want to try it on the entire population of people who are suffering from that disease because there may be important side effects which I don't know. So for that very reason, I could basically first recruit a sample of people and try the drug on them when I run the trial. So basically, for all these different reasons, we generally always deal with samples. And however, the conclusion we draw from the sample should hold good for the entire population. Okay? Otherwise, it's no use. For example, if a pollster make a prediction that 48% of the people are going to vote for a certain party, it should not be just based on the sample of 1,000 people they have surveyed, but it should hold good for the entire population. That's what people expect when they make a prediction. So that's our key challenge, that we look at the sample and from that we make a prediction which holds good for the entire population. In this unit, you have to make probably two kinds of prediction. One is, you look at the sample mean and then you have to predict the population mean. So you look at a sample of your customers and see what kind of ratings they have given you. From that, you make a prediction about the entire population of customers you have and what would be that average rating they will give to your product or services, for example. Okay, so we are trying to calculate the sample mean, which is easy to calculate. If we, as you will see, that we have stat tools, so it's easy to calculate a sample average very quickly. But the key thing is to actually make a prediction about the population average, and the population is something we cannot see because we have not talked or interviewed or surveyed all people in our population. So that's something we are going to do. Look at the sample average and make a prediction about the population average. The other one we would do is to look at the proportion in a sample and predict about the population proportion. Now, proportion is basically percentage. In some cases, the average is not meaningful. Again, going back to our example of election of people voting for party A or party B, there is no average votes. We can just make a prediction that 40% or 45% of people would vote for party A. So that's a proportion of people. But again, that's a sample proportion we are looking at, because we are only surveying a small sample of people. From that sample proportion, we have to make a prediction about the population proportion. How many people, or what percentage of people in the entire population will vote for a certain party. So in this case, it's not an average, but we are making a prediction about a proportion or a percentage. So these are the two things you need to cover when you make predictions from samples to populations. Now, how you collect your sample is pretty important, because although you are not collecting your own data for this unit, it's very important to learn that the way you collect the data can really affect sometimes your results, and sometimes that can really lead you to make conclusions which are quite inappropriate. The commonly applied sampling method is a simple random sampling method, and you will hear a lot about a random sample being taken, okay, a random survey of customers. What does it exactly mean? A random sampling is where a kind of sampling method where each person in that population has an equal chance of responding to that survey, of responding to the survey. So basically, a random sample of customers would be, when you send your, you randomly pick and choose customers whom you would survey, rather than, interviewing a particular segment of your customers. And something can go really wrong in some kind of random surveys. Like a very well-known example is a very well-known pollster prediction for the 2012 election in the US presidential race, where they actually predicted a candidate getting less amount of votes, but the candidate was actually ended up being the winner of the election. And the reason being that there was something wrong with their sampling method. They used landline to survey people and ask their preference of candidates in that election. And the survey was conducted during the daytime. So when you're calling people during the daytime over landline, then obviously you are capturing a certain demographic of the population, people who are available at their home during daytime, and over landline to respond to those calls. And if that segment of the population is inclined to vote in a certain way, or biased towards a certain candidate, then that may actually corrupt your results, because you are considering people's voting inclinations in a general election where people from different age groups or income categories would be voting, so not a particular segment of your customers or your, in this case, your voters. So a truly random sampling is something which is very difficult to do. For example, again, newspapers will often have opinion polls on their online websites, and sometimes you may have responded to some of them, or you may just choose to ignore them. Is it a truly random survey? Some people may think yes, they're giving a chance to everybody to respond to that opinion poll, whoever is coming to that website. But you would be very, very skeptical about accepting that kind of argument, because only certain people who feel very strongly about certain issues may choose to respond to those kind of opinion polls. And the rest of them, although they may have a view that may not be reflected in that opinion poll, So you may not have a real sense of what the majority of people want by looking at the results of those online polls. And because it's not really a truly random sample in that case. There are other variations of random sampling, like a stratified random sampling. For example, let's say you are running a department store and you want to know about the credit card usage habits of your customers. And you may have reason to believe that people's credit card usage habits would be different based on their age or their income. And you may actually segment your customers into different age categories or income categories. And then if you think, let's say, that my customers are mostly in the age range of 30 to 45, then you may pick up more of your sample from that particular segment. So you basically segment your customer base, and then within each segment you randomly do some sampling. And similarly, cluster sampling or convenience sampling, as it is known as, is something where you divide the place where you're sampling into different geographical locations. For example, if you want to know about the public transport facilities in a particular city, and again, you want to survey customers about that, you may like to divide the city into eastern, western, northern, southern suburbs, and then within each of those different clusters, you randomly choose a few suburbs and send your people there. Again, this is not the ideal way, but this is a very convenient way. This is a more cost-effective way for you to do a random sampling. So just pay attention to how the survey data has been gathered, or any kind of data has been gathered, whether it is a truly random sample, because most of our conclusions are based on the assumption that the sample you have picked up is really random. And if it's not, then it's going to lead you to misleading conclusions at times. Thank you.